All right, hello everyone and welcome back. In this video, we are going to look at an example of an AP free response question from the exam. That is an example of a quantitative versus qualitative translation. And that means going back and forth between something that's numerical and then something that's explained conceptually. All right, we open from a question on the 2017 exam, and this is question number 4. All right, a physics class is asked to design a low-friction slide that will launch a block horizontally from the top of a lab table. Teams 1 and 2 assemble the slides shown above and use identical blocks 1 and 2. Both slides start at the same height above the tabletop. However, Team 2's table is lower than Team 1's table. To compensate for the lower table, Team 2 constructs the right end of the slide to rise above the tabletop so that the block leaves the slide horizontally at the same height above the floor as does Team 1's block. All right, question. Both blocks are released from rest at the top of their respective slides. Do block 1 and 2 land at the same distance from their respective tables? Yes or no? So, even if we get the yes or no right, if our justification is incorrect, we don't get any points. All right, so let's look at this. So, quite simply, this is a projectile motion problem. So the block is going to slide down here, and it's going to go projectile motion to the ground. So here's the tabletop, here's the height, here's the tabletop, here's the height. So they are released from the same height. So the blocks have potential energy up here. But this block, it comes down, the potential, I'll say, turns into kinetic, but then some of the kinetic turns back into potential. And really, this here is what we care about. So we have this much potential energy turning into kinetic energy at this height. So I'll put a dot here. This is the potential energy, and it turns into kinetic energy at this height. Over here, we have potential energy, and it goes down farther, and all of this potential energy is going to turn into kinetic energy at this height. So I don't know if you can see this, but I'm going to write it down. The potential energy, mgh, is going to turn into kinetic energy, 1/2 mv squared. And what I care about is what is the velocity, the final velocity of the block as it leaves the table. Because this slide is taller than this one, I'm not talking about to the table, but I'm talking about to the height at which it leaves. Because I have more potential energy over here than I do here, this velocity is going to be greater than this velocity. And so the more velocity you have, the farther over it goes. So since I don't have as much velocity, it's going to plunk down something like that. So, do they land at the same spot? No, they don't land at the same spot. Justify your answer. So I'm not going to write this all out in my video, but what I'm saying is how I might write this out in my justification. So the two blocks are the same, the two blocks are released at the same height above the table. However, because this ledge is higher than this one, there's more potential energy for block 1 than block 2. And the more potential energy I have will give me a greater kinetic energy, and a greater kinetic energy will give me a greater velocity, and a greater velocity will land farther than a lesser velocity. So you just have to explain that in words in this section. So they do not want a bunch of equations, they do not want a bunch of numbers, they want you to justify that as an explanation. All right, so this is a quantitative thinking. So this was like a quantitative thinking, but then I had to write it qualitatively. All right, so let's go back to something quantitative. All right, so in another experiment, teams 1 and 2 used tables and low friction slides with the same height. However, the two slides have different shapes. Both blocks are released from rest at the top of their respective slides. Which block, if either, lands farther from its respective table? So I'm going to turn this block into a dot. It has potential energy, which is going to be equal to mgh. This block over here has potential energy, which is going to be equal to mgh. And the height is the same for both of these. So all of this potential energy here is going to turn into kinetic energy down here. So I'll put a dot, kinetic energy down here. So this block is going to slide down this kind of weird looking hill, and it also, all that potential energy is going to turn into kinetic energy over here. But because this dot is at the exact same height as this dot, it means that the kinetic energies are going to be identical. They have identical potential, they have identical kinetic, therefore they're going to have identical velocities when they leave the table. Identical velocities mean they're going to land at the same spot. The two blocks land the same distance from their table. Let me say that again compared to this one. Notice what was different here. They didn't leave at the same spots from the table. This one left higher, which means that this potential energy was less in the first example. All right, briefly explain your reasoning without manipulating equations. Again, they don't want to see any problem solving here. They want me to say this in words, and they probably would give you a little bit more space to do this. Briefly explain your reasoning. They have the same potential energy at the top. They leave at the same heights at the bottom. They fall the same distance, so the potential energy turns into the same kinetic energy. Therefore, they have the same velocity, same distance. All right, which block, if either, hits the floor first? Which hits the floor first? This question is a little bit tricky. So it looks like, well, this is the same height. Whoops, this is the same height. And so here goes the quantitative part in my thought process. So D equals 1/2 AT squared. So they have the same height, table to floor, so it's the same H. The A is going to be gravity, so that's going to be like 9.8. So the only thing that's going to affect which block hits the ground first is the time that's in there. And the time So the time to hit the floor is going to be identical in both cases. So the time here is going to be equal to the time here. But which block hits the floor first? We have to think about it. We released the block up here. And so this block is going to travel this path. So there's a time it takes to travel that path. And this block is going to travel this path, which is a little bit different, and there's a time to travel this. So we know these two times are the same, so that's not going to affect this answer. But these two times are not the same. And so conceptually, if you look at when this block leaves, I'll draw like a little slope here. Look how steep this slope is. Look how steep the slope is getting less, but it's a steep slope here, which means this block is going to take off like really fast. This block is going to take off a little bit more slowly because it's not as steep there. And so just because that little difference there, this block is going to pick up speed faster, which means that this t here is going to be greater than this t here. And so even though this time is the same, this one's going to be greater, so block 1 is going to hit the ground first. And what they would want in their explanation is kind of what we just talked about, is that these two times are going to be the same, but because of the shapes of the slides, these two times are not the same. And then for us to be able to reason out that this block picks up speed faster, they end up with the same final velocity, but this block picks up speed slower. So if you looked at the average velocity or the average time, this time would turn out to be greater. All right, so that's an example of a quantitative versus qualitative translation where you can see that we're starting with something numerically, but then we're putting it together in conceptual terms. All right, that's the end of this video.